Binomial theorem is an important subject in mathematics. It provides a mechanism to expand binomial expression of nth power easily. The theory finds extensive applications in advanced mathematics, computer science, computational theory, etc. We shall start the topic with basics. In algebra, we often come across a term called monomial, which means a single non-zero term. For example, 21x, 31x cube, 7xy square, 5x square, 58xyz raised to 7, etc. In the algebraic monomial term, three definitions are very common. The index or degree of a monomial is the sum of the exponents of all the variables in the expression. In the example, power of x is 1, power of y is 1, and power of z is 7. Total sum is 9, so the index is 9. A variable is a symbol, often a letter, that represents an unknown number in the equation, expression, or formula. In the example, x, y, and z are called variables. A coefficient is a number or a symbol that is multiplied by a variable in an expression. In the example, 7 is the coefficient. What is binomial? Binomial is an algebraic expression that contains two different terms connected by addition or subtraction. For example, 21x plus 15x square is a binomial. Here there are two terms, 21x and 15x square. They are connected by plus sign. We shall discuss about index and coefficients in the later part of the video. Trinomial is an algebraic expression that contains three different terms connected by additions and subtractions. For example, 21x plus 15x square minus 7xy square. Here there are three terms, 21x, 15x square, and 7xy square. They are connected by addition and subtraction. In the diagram, 2x square is a monomial, 2x square plus 3x is a binomial, and 2x square plus 3x plus 5 is a trinomial. Our focus of discussion today is about binomial. Let us start with a simple binomial x plus y. It is binomial because it has two terms x and y connected by addition. The binomial is a Latin word. Bi means two and monomial means terms. For example, x plus y, a minus b, etc. Okay, what is binomial expression? Binomial expression is the idea of expressing numbers using letters or alphabets without specifying their actual values. Take an example, x plus y square. Here, without specifying any value to x and y, we have expressed the idea of finding the square of sum of two terms x and y. We know that any expression raised to 0 is 1. X plus y raised to 1 is equal to x plus y. X plus y square equals x square plus 2xy plus y square. X plus y cube equals x plus y multiplied by 3 times, which is equal to x cube plus 3x square y plus 3xy square plus y cube. Here x and y are variables, index equal to 3, coefficients are 1, 3, 3 and 1. The beauty part of a binomial expression is that if we know the expanded form of any expression of a plus b, we can find out the expanded form of the expression of a minus b. For example, we can get expanded form of x minus y cube from expanded form of x plus y cube by just changing plus y by minus y in the whole expression. So far so good. How to expand x plus y raised to 11? Do you multiply the sum of x plus y 11 times? It is very tedious and not practical. It is not the right approach. Then what is the solution? This is where binomial theorem comes into picture. Binomial theorem provides the right approach to expand binomial expression. It provides a formula for expanding expressions that are raised to a power such as x plus y raised to n. Okay, good. we shall understand the concept of binomial theorem. We shall start from basics again. A plus b raised to 0 is equal to 1. A plus b raised to 1 is equal to a plus b. A plus b square is equal to a square plus 2ab plus b square. A plus b cube is equal to a cube plus 3a square b plus 3ab square plus b cube. A plus b raised to 4 is equal to a raised to 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b raised to 4. Let us arrange the coefficients of the expanded form. For index equal to 0, the coefficient is 1. For index equal to 1, the coefficients are 1 and 1. For index equal to 2, the coefficients are 1, 2 and 1. For index equal to 3, the coefficients are 1, 3, 3 and 1. For index equal to 4, the coefficients are 1, 4, 6, 4, 1. Why are we doing this exercise? We are doing this exercise of arranging the coefficients of indices one below the other to study the pattern and draw some inferences. For any index, you will observe that the number of coefficients equals index plus 1 and the coefficients follow some pattern as shown. To study the pattern of coefficients, we shall place a small triangle in between the coefficients. You will observe that the value of the coefficient pointed to by the triangle equals sum of the coefficients on either side of the triangle. For example, for index 4, the second coefficient 4 equals sum of third index coefficients 1 and 3. This pattern is observed for all index values. This is called Pascal's triangle. Using Pascal's triangle approach, we can find out the coefficients of nth index if we know the coefficients of index value n minus 1. In the diagram, it is shown below how to find out the coefficients of the fifth index row using fourth index row. From the previous example, we found out the coefficients of fifth row index using Pascal's triangle. The row for index 5 is 1, 5, 10, 10, 5 and 1. With these coefficients of the row, we can simplify binomial expression 25 plus 3y raised to 5. But Pascal's triangle has a limitation. To find out the coefficients of index n, we need to know the coefficients for index n minus 1. For large values of the index, say 36, it is totally impractical. Is there any theorem that enables us to find out the coefficients for index n without having to know coefficients for previous index value? Yes, there is, the theory of combination. Earlier we observed that the coefficients follow a certain pattern. Using combination theory, we can generate values of the coefficients for any index n. The theory of combination says NCR equals n factorial divided by r factorial divided by n minus r factorial. Now we shall arrange the coefficients for various values of index values using combination formula. For index equal to 0, coefficient equal to 0C0, which is equal to 1. For index equal to 1, we have two coefficients 1C0 and 1C1. For index equal to 2, we have three coefficients 2C0, 2C1 and 2C2 and so on. Now we can directly get the coefficients of the nth row without referring to coefficients of the previous row. That is the beauty part of binomial theorem. For example, the coefficients for index equal to 7 are 7C0, 7C1, 7C2, 7C3, 7C4, 7C5, 7C6 and 7C7. Total 8 coefficients. And for expression a plus b raised to 7, we have to just substitute these coefficients. So for any positive integer n, we can expand a plus b raised to n, which is equal to nc0 a raised to n plus nc1 a raised to n minus 1 b plus and so on as shown in the diagram. Note that there are n plus 1 terms in the expanded form. The entire expanded form can be expressed using binomial notation, which is equal to sum of all the terms from k equal to 0 to k equal to n, each term being nck a raised to n minus k b raised to k. Nck is called binomial coefficient. In the example, x plus 2 raised to 6 is expanded using binomial theorem. Here the index is 6. There are 7 terms in the expanded form. Having gone through the theory, we shall solve some exercises to understand the theory better. In the first exercise, you are asked to expand x minus y raised to n using binomial theorem. We know the expanded form of a plus b raised to n. To expand x minus y raised to n, we have to just substitute b equal to minus y in the expanded form. Note that a and b are variables and we can replace it by any value that we want to expand. For example, if you want to expand x minus 2y raised to 5, substitute a equal to x and b equal to minus 2y in the expanded form as shown in the diagram. In the second exercise, we are asked to expand 1 plus x raised to n. The expanded form of binomial expression a plus b raised to n is a general equation where a and b represent variables. To expand 1 plus x raised to n, we have to substitute a equal to 1 and b equal to x. Third exercise is about expanding 1 minus x raised to n. Like previous exercise, we have to substitute a equal to 1 and b equal to minus x. Exercise 4 is about expanding x square plus 3 by x raised to 4. In the previous example, we have substituted a and b by corresponding values. Substitute a equal to x square and b equal to 3 by x and n equal to 4. In the exercise 5, we are asked to expand 98 raised to 5. 98 can be rewritten as 100 minus 2. And in the binomial equation, substitute a equal to 100 and b equal to minus 2 and n equal to 5. Exercise 6 and 7 are our practice. We have reached the end of the video. If you like the video, please do not forget to subscribe. Thank you for watching.